So welcome to the second lesson in Fourier Transforms. We will learn how to solve more problems on Fourier Transforms. So find the Fourier transform of fx equal to e raised to minus mod x. We have learned that the Fourier transform f of u is integral minus infinity to infinity fx e raised to I ux dx. Now fx is e raised to minus x if x greater than or equal to 0. That's the definition of mod x. And mod x is minus x if x less than 0. So it becomes e raised to minus minus, that is e raised to x if x less than 0. So substituting here, your fu becomes integral minus infinity to 0 e raised to x e raised to iux dx when it is less than 0 plus integral 0 to infinity e raised to minus x e raised to iux dx. So that will be integral minus infinity to 0, take out the e raised to x into 1 plus iu dx, plus integral 0 to infinity e raised to minus x into, take out the minus sign, so 1 minus iu dx. Now integral of e raised to x is e raised to x, so this becomes e raised to 1 plus iux by 1 plus iu within the limits minus infinity to 0, plus e raised to minus x into 1 minus iu divided by derivative of this, which is minus of 1 minus iu, which is iu minus 1 within the limit 0 to infinity. So when I substitute, e raised to 0 is 1, so you get 1 by 1 plus iu. 1 by e raised to infinity becomes 1 by infinity, which is 0. This becomes again e raised to minus infinity, which is 0, minus 1 by iu minus 1. So that will give you 1 by 1 plus iu minus 1 by 1 minus iu. Because I'm making it plus, so it becomes plus 1 by 1 minus iu. Take the LCM, it is 1 minus I squared u squared. So that is 1 minus iu plus 1 plus iu, which is 2 by 1 plus iu squared. And that is the Fourier transform. Coming to the next question, find the Fourier transform of fx is equal to 1 plus x by a when x lies between minus a to 0, equal to 1 minus x by a when x lies between 0 to a, equal to 0 otherwise. So as usual, f of u, the Fourier transform, is integral minus infinity to infinity fx e raised to iux dx. That will be integral minus a to 0, 1 plus x by a e raised to iux dx, plus integral 0 to a 1 minus x by a e raised to iux dx. So when you integrate, you apply integration by parts, the order is right. So it is 1 plus x by a e raised to iux by iu within the limits minus a to 0, minus integral minus a to 0, derivative of this is 1 by a e raised to iux by iu dx. Again, the second integral you integrate by parts, so you get 1 minus x by a e raised to iux by iu within the limit 0 to a, minus integral 0 to a, this is minus 1 by a, so it becomes plus 1 by a e raised to iux by iu. So when I substitute, this becomes 1 plus 0 by iu, because e raised to 0 is 1, and when it is a, it becomes 0. Minus 1 by aiu, this will be e raised to iux by iu within the limits minus a to 0. Again, this will give you 0 minus 1 by iu. And plus 1 by a, integrating, you get e raised to iux by iu. I'm taking out the aiu here within the limit 0 to a. So this becomes 1 by iu minus 1 by a I squared u squared. And this will give you e raised to 0 is 1, 1 minus e raised to minus iua. Again, this is minus 1 by iu plus 1 by aiu, 1 by a I squared u squared e raised to iua minus e raised to 0, which is 1. So this will be the 1 by iu gets cancelled. You get 1 by a I squared is minus 1, so the minus minus cancels. You get au squared, 1 minus e raised to minus iua plus 1 by, this becomes minus 1 by au squared e raised to iua minus 1, because I squared is minus 1. So when you open the bracket, you get 1 by au squared minus e raised to minus iua by au squared minus e raised to iua by au squared plus 1 by au squared. So that is 2 by au squared. Take out minus 1 by au squared out. So you get e raised to minus iua plus e raised to iua. So that is 2 by au squared minus 1 by au squared. E raised to I theta is cos theta plus I sin theta. So it becomes cos au minus I sin au, because e raised to minus I theta is cos theta minus I sin theta, plus cos au plus I sin au. So the minus I sin au gets cancelled and you get 2 by au squared minus 1 by au squared, 2 cos au. So that is 2 by au squared, 1 minus cos au. I'm taking out 2 by au squared. Quite a lengthy problem, wasn't it? Okay, coming to the last problem for this class. Find the complex Fourier transform of e raised to minus a squared x squared, a greater than 0. Hence show that e raised to minus x squared by 2 is the self-reciprocal with respect to this Fourier transform. So first we will calculate the complex Fourier transform and then explain what is the self-reciprocal. So complex Fourier transform is integral minus infinity to infinity e raised to minus a squared x squared e raised to iux dx, fx e raised to iux dx. So that is e raised to minus a squared you take out, x squared minus iux by a squared dx. Now I'm going to complete the square, so I'll divide. How do you complete the square? Take the coefficient, that is minus iu by a squared of x, divide by 2, that is minus iu by 2a squared, and square it. So it will be I squared u squared by 4a raised to 4, and I'm adding and subtracting that. So this becomes integral minus infinity to infinity e raised to minus a squared. The first three terms will give you x minus iu by 2a squared squared, and this is e raised to a squared is there into minus 1 u squared. I squared is minus 1, minus minus cancels, so you get minus 1 u squared by 4 e raised to 4 dx. So this is minus infinity to infinity e raised to minus a squared, x minus iu by 2a squared squared, and this becomes e raised to minus u squared by 4a squared. The a squared and a raised to 4 cancels. So you can take out e raised to minus u squared by 4a squared, and it becomes integral minus infinity to infinity e raised to minus a squared into x minus iu by 2a squared the whole squared. Now put a into x minus iu by 2a squared as t. So when you differentiate, a dx equal to dt, or dx is dt by a, and as x varies from minus infinity to infinity, t will also vary from minus infinity to infinity. So fu becomes e raised to minus u squared by 4a squared, integral minus infinity to infinity, e raised to minus t squared, because the whole thing is t, minus t squared dt by a. That is e raised to minus u squared by 4a squared by a, integral minus infinity to infinity e raised to minus t squared dt. Now in calculus we have seen this is a gamma function. Integral minus infinity to infinity e raised to minus t squared dt is root pi. You can refer to gamma functions or my earlier video or course for gamma functions. So f of u becomes root pi by a. This entire thing is root pi by a e raised to minus u squared by 4a squared. This is the Fourier transform. Now if I put a squared is half, we get f of u will be f of e raised to minus x squared by 2. And that will be root pi by 1 by root 2. A will be 1 by root 2. E raised to minus u squared by 4 into half. So this becomes root 2 pi e raised to minus u squared by 2. So the Fourier transform of e raised to minus x squared by 2 is a constant times e raised to minus u squared by 2. That is the meaning of saying that e raised to minus x squared by 2 is self-reciprocal under this Fourier transform. So we have learned how to solve some more problems on Fourier transforms. I hope this was useful to you. Thank you.